Okay, now that we know information about parallelograms and we know how to prove if something's a parallelogram, why don't we talk about some special parallelograms? Before we do that, let's remember the properties of parallelograms. So take a moment, fill this out, try to do it from memory if you can, and see if you remember our properties of parallelograms. All right, so check those, and you'll notice most of these properties deal with the sides and angles, right? Just that fifth one talks about diagonals. So to create these special parallelograms, we're going to take our quadrilateral and do something with the sides and angles. So notice this. If all sides are congruent, then it forms what we call a rhombus. Okay? So by definition, a rhombus is any quadrilateral that has four congruent sides. All right, so you'll often see the markings like this, right? We can call this quadrilateral A, B, C, D. And if you see all four sides are the same length, then it's also a rhombus. Okay, we've got three properties of rhombuses we want to use in our work today. Let's talk about the first one. So the first one says if a quadrilateral is a rhombus, then it's also a parallelogram. And that kind of makes sense with our title, right? We're talking about special parallelograms. Okay, so again, if we have a rhombus, then we have a parallelogram. So if you look at this diagram, again, I can tell it's a rhombus because of these four congruent sides. Or I could tell you in words, right? A, B, C, D is a, oops, let me make that a little cleaner, is a rhombus. And if we know that, then we know A, B, C, D is also a parallelogram. And that means those five properties we just talked about up here, they're all true for rhombuses too. So we could say BC is congruent to AD. Well, actually, we already knew that, but we could say angle B is congruent to angle D, right? Opposite angles are congruent. Your diagonals would bisect each other, all that lovely stuff. Okay, the second property, the second theorem says that if a quadrilateral is a rhombus, then its diagonals are perpendicular. All right, so again, if we have a rhombus, now we can say the diagonals are perpendicular. So what that does is that creates angle measures for us. So we would be able to say the diagonals AC and BD are perpendicular. And this is great because remember, perpendicular gives you what kind of angles? That's going to give you 90-degree angles. So we're going to be able to say, right, in ABCD, these are all 90-degree angles, which gives us right triangles, which gives us a 90-degree measure. That's great for doing Pythagorean theorem. It's great for proving triangles with HL. So that's something neat to go with our proofs. Okay. Next, our last property that are specific to just rhombuses is that the diagonals each bisect a pair of opposite angles. Okay. So what that means is that the diagonals, right, AC and BD, are going to cut their opposite angles in half. So obviously AC is going to cut angles BAD and BCD in half. BD is going to cut the angles it intersects in half. All right, so oops, let me fix that. Let's go ahead and write that down. All right, so first I can say that angle ABD and angle CBD are congruent, and this is created from that diagonal BD. So just a side note here. Angle ADB is congruent to angle CDB, again, because the diagonal bisects each other. And that's these angles right over here, right? So ABD, CBD, ADB, and CDB. And we can say the same is true for the other diagonal. All right, and this is created from that second diagonal, diagonal AC. And again, you can see that in this diagram right over here to your left. So let me draw these in as well. So we would know that BAC is congruent to DAC, and also BCA is congruent to DCA. And you'll notice those bisected angles are all the same because your opposite angles are congruent since our rhombus is also a parallelogram. So that's a great connection between the two. All right, so let's move on to example one. Let's take a look at this rhombus MNPQ, and I realized I just forgot to write down those letters, but that's a rhombus, and the measurement angle n is 120 degrees. Let's find all the other angle measures. How do we do that? All right, so just draw those, write those letters in, draw those congruent marks. And we know a measure of angle N is 120, so I'm going to draw that in. Now, how do I find the rest of these angles? Well, if I think the definition of rhombus doesn't tell me anything about angles, and I only know angles that deal with the diagonals, so how do I figure out the angles of the opposite angles or whatever in this rhombus? Well, remember that very first theorem. If you have a rhombus, this is also what kind of shape? A rhombus is also a parallelogram. So think about what you know about angles in a parallelogram. One, your opposite angles are congruent, and two, your consecutive angles are supplementary. So we can use that. Oops, let me clear that up. That's supplementary. Okay. So we can use that information now to figure out the rest of these missing angles, right? So that means angle N needs to be congruent to angle Q because we have opposite angles. So that means the measure of angle Q is 120 degrees. Measure of angle Q is 120. There's one. Well, since we know our consecutive angles are supplementary, we would know that the measure of angle N plus the measure of angle P should add up to 180 degrees, right? So plugging in 120, I can figure out the measure of angle P is 60 degrees. All right, and we're almost done. Since angle M is congruent to angle P, since our opposite angles are congruent, I can say the measure of angle M is also 60 degrees. So there's 1, 2, 3, those last three angles. Okay, let's take a look at example 2. TVWX is a rhombus, so we know all four sides are congruent. Let's find each measure. So how do I find TV? If you notice, I'm not given anything about TV. I'm given information about TX and WV. But what did I just say about rhombuses? What do you know about rhombuses and their sides? Well, we said all four sides are congruent, right? So WX should be congruent to TV, which is, or excuse me, congruent to TX, which should be congruent to TV, which should be congruent to WV. So since TV is congruent to all the other sides, if I can just figure out one of those sides, I'm solid. And how do I do that? Well, let's go ahead and solve for B and plug in our information for B. So 3B plus 4 should equal 13B minus 9. All right, so there's B. We get 1.3 or 13 over 10. So once we know B, we can plug it in to find, for example, TX, which is 3B plus 4, right? And then use that to find TV, since they should be the same thing. All right, since TX is 7.9, that means TV should also be 7.9. Okay, looking at the second part, before I do that, I'm just going to go ahead and erase those highlights so I can use a diagram again with the angles. All right, so now we want to find the measure of angle VTZ. Well, first let's figure out which is the angle VTZ. Well, VTZ is this little one right here in the upper right corner. Well, what do I know about that angle? Well, since this is a rhombus, the diagonals are going to bisect opposite angles. So that means this angle VTZ is congruent to this angle XTZ, right? All right, so I know that then that the measure of angle VTZ is 5A minus 5. I'm getting closer, but I don't have a number yet. Now the question is, well, how do I find A? Well, where else do you see A in the problem? Well, I see A right here, this 14A plus 20. And that points at this angle right here in the middle. And do you guys remember what are the diagonals in a rhombus? They not only bisect the opposite angles, but they also make what kind of angles in the center? Well, they make 90-degree angles because these are perpendicular, right? So since XV, oops, sorry about that. Let me scroll back down. So since XV, that diagonal, is perpendicular to WT, we know that the measure of angle VZT should be 90 degrees. So I can use that to solve for A, then plug it back in to solve for the angle VTZ. All right, so I'm going to solve for A by plugging in 14a plus 20 right over here, and then I get a equals 5, plugging that in to get angle VTZ, that measure being 20 degrees. All right, so make sure you come back to class with questions if you have any questions on these. I know these can get a little complicated because you have to look at a couple pieces together. We're going to skip over the proof because I'm going to go over that with you when you come back to class. Now let's go ahead and talk about rectangles. So I added this in here because I realized I forgot to put in a place for definition of rectangle. So we're going to start up here. So we talked about quadrilaterals being equilateral, that's creating a rhombus. Now let's talk about quadrilaterals that are equal angular, and that's what's going to make a rectangle. Okay, so a quadrilateral that has four congruent angles is what we call a rectangle, and we can actually go further and say these four congruent angles should equal what number? Well, remember a quadrilateral's interior angles add up to 360. 360 divided by 4 gives you 90-degree angles. So each angle is 90 degrees. So just keep that in mind because that also gives us right triangles and things we can use with that 90-degree angle. Okay, now our first property of a rectangle is being very similar to our first property of rhombuses in that a rectangle is also a parallelogram. Okay, so if a quadrilateral is a rectangle, then it's a parallelogram. How do I know if it's a rectangle? Look for these four 90-degree angles, right? So that tells me ABCD is a rectangle. And if I know it's a rectangle, then ABCD is a parallelogram, which means those five things, I'm not going to scroll up this time, but those five things at the top of your front page are all true for rectangles. So opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, diagonals bisect each other, etc., etc., etc. Okay, cool. Then we have one other thing that is true for rectangles. So by making those four angles 90 degrees in our quadrilateral, not only do we know our rectangle is still a parallelogram, but we also know that um, our diagonals are congruent. All right, so now if I know I've got a rectangle, not only will the diagonals bisect each other because a rectangle is a parallelogram, but we also know that our diagonals are congruent. So that means AC is going to be congruent to BD. And again, that's only true for rectangles. Please note this does not mean the diagonals bisect the angles. That's the common error I see over and over again with this. That's only true for rhombuses. Okay? Um, Now, one last thing to make a note, if we are both equilateral and equiangular in our quadrilateral, that's how we create a square. All right, so again, if it's both equilateral and equiangular, we have a square, which means a square is also, oops, let me clear that up. Someday I'm going to get a hang of writing on this, but until then, please bear with my bad handwriting. So again, since a quadrilateral is both equilateral and equiangular, the square is not just a square, it's also equilateral, which makes it a rhombus, but equiangular makes it a rectangle, and since both rhombuses and rectangles are parallelograms, this is also a parallelogram, which means a square inherits everything that we just listed. Diagonals are congruent and bisect each other and bisect opposite angles and all that good stuff. Opposite sides are parallel, congruent, etc., etc., etc. So that's something to make a note of if you see a square, which would be drawn like this, right? So you'd have four congruent sides and four congruent angles, or you'd see the word square. Okay, let's do a couple examples and then we will be done with this video. Okay. So there's our rectangle GFED with our four congruent angles. Then let's look at what we're looking for. We're looking for the length of FD. Well, what is FD? Well, let's connect it and we'll see FD is a diagonal, right? So we're looking for a diagonal. And we also know the length of FD and the length of GE, and GE is our second diagonal. So what do I know about diagonals with this rectangle, right? That's the question. Well, diagonals should be congruent. So that means FD, oops, should be congruent to GE, which means my equation should be 2y plus 4 is equal to 6y minus 5. Then I can solve for y and plug it in to find FD. All right, so there's the work. So I got y equals 2.25 or 9 over 4. Then I plugged that in to get FD, which is about 8.5. or exactly 8.5 actually. All right, finally, let's go ahead and do the second example for the rectangles. We're going to show the diagonals of square EFGH are congruent perpendicular bisectors of each other. So again, when we're doing our coordinate proof, you want to think about how would we show these things? How do we show congruence? How do we show perpendicular? How do we show bisectors? And all that good stuff. So let's go ahead and draw on these diagonals. So I'm going to connect F to H just to visualize that, right? And E to G. And if I want to show three things, right? Congruent, perpendicular, bisectors. Let's talk about congruent. Well, how do I know if things are the same measure? I'm going to use that distance formula. Okay? Then next we want to think about perpendicular. What does perpendicular mean? Perpendicular in terms of our coordinate plane would be opposite reciprocal slopes. And finally, we've got bisector. And how would I show a bisector? You could do a bisector in two ways. You can show that the sides are all cut in half, but I'm using distance formula, but I actually prefer using the midpoint. So if they both intersect at the same midpoint, they're bisectors of each other. So I'm going to use that midpoint formula. All right, so those are the three things I want to do, and I'm going to do them one at a time. So let's go ahead and show that the diagonals are congruent. So we're going to use that distance formula on the points FH and EG. Okay, so there's my distance formula. So I just put that congruent to show you which part I'm doing there. But again, distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. If I go ahead and use FH, remember it doesn't matter. One's going to be x1, y1, one's going to be x2, y2. That's an x. And just plug it in. So I'm going to use square root of 0 minus -1 squared plus -4 minus 3 squared. And that's going to work out to some number. Let's check and see what we get. Okay, so there's that work, and I get square root of 50, but remember, always do simplest radical form, so simplify if you can. That's going to give me 5 square root 2. Okay, we're going to do the exact same thing, but now with E and G. Again, anything, just start, pick one point. So we got x1, y1, x2, y2, and plug it in and solve. And let's see if we get 5 square root 2 again. All right, so now we see they're both 5 square root 2. Awesome. This means FH is equal to EG. Therefore, FH is congruent to EG. So make sure you have that summary there. Okay, now let's talk about opposite reciprocal slopes. We want to show that our two diagonals have opposite reciprocal slopes. So let's go ahead and find our slopes, right? So we're going to figure out perpendicular right over here. Well, the slope of FH, remember what you can do is you can do slope formula, or you can count rise over run, which is what I'm going to go ahead and do here. I'm going to go down and over, and I see that's down 1, 2, 3, 4, 5, 6, 7, and over 1. So I'm going to go down 7 over 1 to get a slope of -7. Now, what would the opposite reciprocal of that be? That's going to be our aim for EG. Well, hopefully you remember the opposite reciprocal of -7 is positive 1 over 7. And that's what we're looking for the slope of EG. And again, you can count or you can do your slope formula. It's up to you. So I'm going to go left to right, up 1 over 7, which is great. So that's positive 1 over 7. So since they're opposite reciprocal slopes, we can say FH is perpendicular to EG. That's 1 done, 2, and now 3. How do I know they're bisectors? So what I want to do here is show they have the same midpoint. So finally, here in orange, I'm reminding you what the midpoint formula is, and we're going to go ahead and find the midpoint of FH and also the midpoint of EG. All right, let's ignore that rectangle there. So let's go ahead and do our work, and we should see the exact same point. And what do you know? We get -1/2 and -1/2 for both of these points. So therefore, we can say that FH and EG bisect each other. And that was the third thing that I need to do, and this is done. So I know this video was a bit long. Thank you for bearing with me. Please come back with questions because I know this is where things can start getting confusing because we're throwing in different types of quadrilaterals. See you guys in class.